Hello everyone, welcome to the day 3 of Core Java. In our earlier videos, we learned about Java variable, typecasting, and difference between primitive generalized and non-primitive. So now we'll be learning our next topic, that is Java operators. What are Java operators? Operators are symbols or keywords that tell Java to perform specific operations with variables and values. What are specific operations? So any specific task that we want to perform on any variable and values, we use these tools that are known as operators to perform a specific task. So these are the type of operators available in Java that are arithmetic operators, relational, logical, bitwise, assigning, and conditional ternary operator. Now we will be learning about each of the operators in detail. So first we will learn about arithmetic operators. As the name suggests, arithmetic, which means counting of numbers. And how do we do that counting? Use specific symbols like addition, subtraction, multiplication, division, and modulus that we all have learned about in our school. So we use arithmetic operators to perform such operations on our variables or values. As we can see in our first example, that is 5 plus 3 results in 8. It's a simple addition we did or learned in our school time. So we can do that in Java also by using only three symbols, that is addition, subtraction, multiplication, division, and modulus. So what is modulo operator? Modulus operator. So when we do a modulo of a number, that is 10 modulo 3, it returns us remainder of division. So arithmetic operators are mainly used to do all the basic math operations. Now let's see an example of arithmetic. So let's take two variables. Now let's perform an arithmetic operation on it. See the value. So as you can see, we got the output as 30. To perform the basic arithmetic operation on it, a plus b, and we got the value is 30. We can also perform subtraction, multiplication, and division. Let's also see an output of subtraction operation. We got the value as minus 10, as our a was 10 and our b was 20. So we got an output as minus 10. We can also perform division, multiplication, and modulus as like that. So we have our plus operator that is used to perform addition. But it is also used to do one more thing in Java. What it is? We can add the value. If we want to print any string to our terminal, then we can use the plus operator. This is the second use of our plus operator that we do. So let's print the value of addition of A and B. So let's take another variable for it. And now we will the value of sum. So now this operator will work to print the string. And we can see the output as sum of A and B is 30. It's the second use of our plus operator. So this is all about our arithmetic operator. We can perform any arithmetic operation in Java on variables and values. Now let's proceed further. Next, we have our relational operators. As the name suggests, relational. What does relational means? Relational operators specify relation between two variables or values. They help us to compare values and make decisions. The symbols of our relational operators are equal to, not equal to, greater than, less than, greater than or equal to, less than or equal to. We can see the first example, 5 greater than 3, which results in true. So this specifies the relation between the both, that 5 is greater than 3. Is it true? Yes, it is true. So we get the output as true. Our relational operators return the value, give us a Boolean result that is true or false. Now, next example is 10 is less than or equal to 4. 7. So, yes, this is not true. So, we get the value as false. Now, let's see a practical example of a relational operator. So now let's take an example and see if A is less than B. We want A is smaller, else we want to that B is smaller. Here we are going to check whether A is smaller or B is smaller. So now let's run our program and we got the output as A is smaller. So A is smaller is compared using the relational operator less than. So here it checked A is less than B. This is true. It gave the Boolean result as true. So the program entered the block and we get the output as B is smaller. This is the use of relational operator. We have many relational operators less than, greater than, less than or equal to, greater than or equal to. So we can make use of all these operators. Now let's move further. Next, we have logical operators. As the name suggests, logical operators, they check the logic. These operators are like the decision makers. They help us control the flow of our program based on several conditions that we apply. So as we can see in our first example, we are checking whether our both of the conditions are true or false. Evaluates true or false. So it will first check the first condition. Here 5 is greater than 3. Yes, it is true. And 2 is less than true. Less than 4. True. So our first relational operator pair 5 greater than 3 results to true. And our second relational operator pair 2 is less than 4 also results to true. As the logical AND operator got true and true, so it gives the output as true. So the AND operator works like that. If it gets both of the values as true, then it results the output as true. If it gets any of the value as false, then we get our output as false. So this is our logical AND operator. Then we have our logical OR operator. Logical OR operator basically checks for any one value. It checks for both of the values, but if it gets any of the value as true, then it returns the result as true. Then we have our logical NOT operator. It gives us the opposite value of what is the result. So here the result was 10 is greater than 5. Our result was true, but we get the final result as false as we have applied the logical NOT operator here. So now let's see a practical example of logical NOT operator. Okay, so let's check if let's take two more variables and C is equal to 30, D is equal to 40. Now let's check if A is less than B and B is less than D. We want the output as A and K is smaller, and if that is not true, the output as B and P. Now let's run our program. So now here we can see we get output as A and C is smaller. Why we got the output A and C is smaller? Here A and B, A is less than B, condition evaluated to true, and C and C less than D, condition also evaluated to true. So when we got true and true, the logical AND operator gives the final result as true, and then the program enters this block and we got the output as is smaller. So this is the use of our logical AND operator. So they basically compare both of our conditions and then gives a Boolean result as true or false. So these are our logical operators. Next, we have our bitwise operators. So they are somewhat like, as we can see, bitwise and or that are somewhat like our logical operators, but they are different from that as they compare individual bit and also return the result as a bit. So here we can see bitwise and, or, XOR, NOT, left shift, right shift, and unsigned right shift. What does bitwise and? Bitwise and compares the values in binary, that is 0 to 1, which is the binary form of 5, as we can see in the first example, and 3, binary form of 3 is 0, 0, 1, 1. And when we perform AND operation, that is 1, 1 evaluates to 1, 0, 0 evaluates to 2, And then 1 0 value is 2 0 and 0 0 value is 2 0. So we get the final result as 0 0 0 1, as we know that 8421 rule, by which we get our value as 1. So our next example is right shift, that is 8 right shift 2. When we do right shift, we shift the value right hand side by 2 bits, as here we have done right shift by 2 bits. So when we shift it, as the binary form of 8 is 1000, when we right shift it to two values, we get the output as 2. So basically, bitwise operations are used for low-level operations on bits and bytes. Now let's see a practical example of bitwise operators. So here, what is this? Let's print the value of A, bitwise and C. Now, can we do that with logical AND? Let's try. No, we cannot do with logical AND. Why? It's giving me an error. What is this error? The error suggests bad operand types for binary operator, first typing and second typing. So that was a logical AND operator, which is used to compare two conditions and give us the Boolean value. But here I am trying to compare to int values and return the result. So that's why it is giving me error. So I cannot use logical operator here. This is the difference between bitwise and logical. Here we can use bitwise operators as it will compare the binary value of A and B, and then it will be giving me the result. Now let's run it. Now here I am getting the value as 0. Why I am getting the value as 0? Let's see it. So when we convert A into its binary form, what will be its binary form? Its binary form will be 1010. And what will be the binary form of 20? Binary form of 20 will be 10100. So when I will be performing AND operation between the both, after performing bitwise AND, what will I be getting? 0 gives me 0, 1 gives me 0, and then I have 1 which also gives me 0. 0 gives me 0, 1 gives me 0, 1 gives me 0, and 1 also gives me 0. So I get the 0 as my binary output. That's why I'm getting 0 as my output. So this is how I can use my bitwise operator for performing bitwise operations. Now let's also see an example of right shift. So let's perform right shift on A. So let's perform right shift by 2 bits on A. This. Let's see what we'll be getting as an output. So we got 2. How I got 2? After right shift of A. So I had its binary version as 1010. So when I will be moving it to 2 bits right, so what I will be getting as an output, I will be getting as 0010. So this will be my final output after right shifting A to 2 bits, and that's why I'm getting the output as 2. So this was all about our bitwise operators. Now let's move forward to our assignment operators. What are assignment operators? As the name suggests, assignment means assigning a value. We use them to assign a value and update values. As you can see, our symbols assign, add and assign, subtract and assign, multiply and assign, divide and assign, modulus and assign. So our first example suggests, which is x plus equal to 5, which is a shorthand for x equal to x plus 5. We are adding 5 to x and then updating the value of x. So these are our assignment operators. Now let's see a practical example of it. Now let's do a shorthand for A. Now let's print the value of A. Let's see what we've written now. Now we get the output as 15 as we have done the, as first we have assigned, we have used a normal assignment operator that is equal to assign a 10 value to our variable a. This was our first assignment operator. Then we updated the value of a by using a shorthand that is a plus equal to 5, which means a is equal to a plus 5. And when we printed the value of it, we got the output as 50. So these are our assignment operators. We can perform all these operations by using subtraction, division, modulus, etc. Now let's move forward. Our next operators are unary operators. Unary operators work on a single operand as name suggests, unary. So we have these symbols, unary plus, minus, increment, decrement, and logical not. So as you can see in our first example, plus plus x. What is this? This is pre-increment operator. Pre-increment operator first increases the value and it increases the value by 1. What are decrement operators? Decrement operator decreases the value by 1. What are logical not operators? Logical not operators are that opposite the value. That is, it changes the value. That is, if we have 2 and we have applied logical not operator before it, we get the value as 4. So now see a practical example of unary operators. So our most famous unary operators are increment and decrement operators. So increment and decrement operators. So let's see an example of increment and decrement operators. So these are of two types. Pre-increment and pre-decrement. And you also have post-increment and post-decrement. So let's see a practical example. As we have our variable in a equal to 10, let's take another variable where we are let's first see an example of pre-increment operator. Now we are using pre-increment operator before a. Now let's print the value of both a and c. This is our a. And let's also print the value of c. Let's see the value of both variables. So here we can see that we get the value of both of the variables as 11. So what it did, it used pre-increment. As the value for variable a was 10, but when we used pre-increment plus a, it first incremented the value of a and changed it to 11, and then it assigned to the value through c. So as we can see in our output, a is also 11 and c is also 11. Now let's see what is the difference between pre-increment and post-increment. Now let's change this operator to post-increment. Okay, now let's print the value. So now when you print the value, we see the value of a as 11, but the value of c is 10. So this is the difference between pre-increment and post-increment. Our post-increment operator first assigns the value, first the value is used, and then the value is updated. So first the value is used as the value of a is assigned to c, and then the value is updated. As we can see, the output of c is 10 and a is 11. So this also works with pre-decrement and post-decrement. So this was about our increment and decrement operators. So this was all about our unary operators. Let's move forward. Next is our conditional ternary operators. Our conditional ternary operators are a shorthand for our simple if-else statements that I was using in the program when I was explaining you about other operators. I have not still told you about if-else statements. So when I will be telling you about conditional statements, then it will be more easy for you to understand about the conditional ternary operators. Then I am just telling you about that this is also an operator that is available in Java, but we will study about it in our later classes when we have studied about our conditional statements. So, thank you everyone for watching this video and we will meet in our next video.